KILT, which is the parachain, went live on Polkadot like in 2021, I think. First on Kusama and then moved over to Polkadot, but that's very technical. So what does KILT do? KILT is an implementation of DEIDs and verifiable credentials, and that is basically, when you put it together, this is what decentralized digital identity is. So we implemented alongside the evolution of the standard, I would say. So it started in 2016, but of course, in the beginning, it was total chaos and everyone had totally different ideas. And then there were the blockchain people who said it must be a blockchain standard. And then there were the non-blockchain people who say, go away with your blockchain. And then you have to find compromises so that it works on both ends. Then it was somehow everyone had the feeling like in 2019, okay, actually this thing should work and we can actually start implementing on things. And then we started implementing it. But still, it was not standardized. The standardization of it was another fight because we wanted to have an international standardization body who said, okay, this is actually the standard for digital identity for now and forever and for everyone. And if just 300 industry companies come and say, yeah, we think that, then this doesn't happen. So you need a trusted entity again, like an international standardization body who says, we agree this is the future of digital identity. And we chose the W3C for that, the World Wide Web Consortium, because they are very well known and are very much respected because they gave us things like HTTP, and HTTP is used by everyone. So this is the right place to go. The problem is that, of course, in the identity working groups there, first people that you find with the most power is Apple, Google, and Facebook. And we're not really interested in standardizing the DIDs and verifiable credentials. So that was another political fight, which took a couple of years. Finally, the standardization then happened in 2022. And since then, we are in the process of seeing adoption from industry, from governments, and so on.
I'm from Italy, been living abroad for the past 10 years. Especially the online and digital identity has been a topic that I've kind of liked since I started digging a little bit more into how online interactions work. My master thesis was on SSI and digital identity, and I've just kind of liked the topic and kept digging deeper and deeper, and that's what brought me to KILT eventually. I'm a core protocol developer now. Because of my studies and my previous experience, I was also already in contact with some peeps with like the community of the decentralized identity space. So I also acted as the liaison between the company and the identity industry out there. The whole point why we do DIDs and verifiable credentials is because they are a standard. Like it's an evolving standard, but it is a standard nonetheless, which has been put together not by crypto people, but by people trying to solve real-world issues.
When you have something like decentralized identity, you have to look at what is actually your target group, who are your potential customers. You cannot really with users, let's say. And some people would probably say, yeah, let's focus on a vertical. We said, actually, no, because we are doing something which is so general like HTTP. So we have to be totally agnostic of who's actually using it. And the second decision that we made is, if we come with something so complicated like Web3, which requires a mind shift, we definitely need a lot of trust. So first, of course, we need standardization. But second, we need huge companies and governments to use that stuff. Because then the smaller companies can actually say, okay, even though it is blockchain, even though it is Web3, even though I don't know what it is, and even though I probably don't trust the whole thing, if those big ones use that, then I can dare to do it as well. So we said, we have to concentrate not on one vertical, but we have to concentrate on the big guys. And if you ever worked with a huge company, it is very time-consuming, I would say, because they don't make decisions like, oh, that's a great idea, let's implement that. It always takes years. So all the implementations that we have took us years from 2022 to 2024 now to actually get the first pieces of adoption. Now it's getting faster. It's becoming much faster because now we have people like Deloitte or parts of the German government which use DEIDs and verifiable credentials and which use KILT. And now banks are calling, insurance companies are calling, and so on, because they see, okay, the big ones already work with that, so we can dare to do that as well. Very often when big companies implement software, they do that as a saving case. So they try to save cost with it. And this is with blockchain not always possible, I would say. For the Deloitte case is a profit case. So what they have, they do KYC and KYB for like 100 years. So they basically can state who you are and give you a piece of paper in the past with a stamp saying Deloitte says you're actually you, or your company is actually this company and you have the right to make transactions for this company if you want to buy other companies or something. So this is where Deloitte is known for, and they have a lot of trust out there in the world, everywhere. They're present in basically every country of the world, and they are auditing the governments. So what they say is normally also accepted by the governments. And they had this KYC, KYB business, but in a very, very small form, because it's only for really big transactions that would be used. And it was all on paper. They said, okay, there's a trust that we have, which we can bring to the market. How can we actually blow this up so that it's getting really big? We will need the internet for it. So it must be possible to access this service, not via paper, but via internet. And if we are going into the internet, should we go Web 2, or shall we maybe leapfrog to Web 3 and use the concept of Web 3 already? And while we do this, there's a new international standards called DEID and verifiable credentials. So how can we bring it together, Web 3 and DEIDs and verifiable credentials? And the solution for that, or the answer to that, is actually KILT. And this is why they ended up with us. And now you can go on a website and say, I want to make a KYC, and you can make your KYC process with Deloitte, pay them for that. They get a lot of money for it. And what you get in return is a verifiable credential, which says you are KYC'd by Deloitte. And unlike the KYC that you do with your bank, which you can only use for that single bank, and if you want with another bank, you have to make the KYC again, the Deloitte KYC credential is in your digital wallet on your computer, secured by your DEID. So you can use that as often as you want without Deloitte noticing that you use it. And Deloitte is right now the only company in the world which actually offers this feature to people. So first of all, you can do it without a blockchain. So DEIDs and verifiable credentials work totally fine without blockchain. There's DEID implementations without blockchain, and they're totally good. But there's certain things where we had the feeling that it would be better to do it with a blockchain. One example. So if you have my driver's license, for example, if I drive too fast or drunk or something, they can take it away from me. I don't have the plastic anymore. This is not possible with data because I can always keep a copy. So how can you actually manage that to take away a piece of data from people? You have to store the validity of the data somewhere. And this is either on a central server or it is on a blockchain. If it is on a central server, then it becomes a little bit more dangerous even than Facebook, because if all the validities of all the verifiable credentials of all the people in the world sit on one server, then somebody probably controls the server, and this person is the most dangerous person in the world then. So here we have a clear case where we want something which cannot be changed by a person and which is also not owned by a person. And this is exactly what public permissionless blockchains are good for. So we use a blockchain to store the validity of the credential. And only the issuer of the credential, which is, for example, the university, can say, now we found out that he flunked the test and actually he shouldn't be entitled to be a master of computer science or something. And then they can say, okay, we take this away. And then they just say on the blockchain, we invalidate this credential. The guy who has the credential, for him it still looks perfectly normal, but if he applies with that for the next job, then the employer will probably look on the blockchain if it is a valid credential and say it's not. And then they see, actually you're not a computer scientist and maybe you shouldn't apply for that. So our DID is basically compatible, or a verifiable credential is compatible to others and can be read by those guys. And if it is standardized, then it is compatible. So you're not having your data at this central internet hub like Google. You have all the data in your computer. And if this website A needs to know from me that I'm over 18, I'm going to send them proof that I'm over 18, but I'm not going to send them my home address, for example. And then another service will probably want to know, maybe if it's a game, and they want to know if I already are on level 25 at least. So I send them a proof that I'm on level 25, and they don't need to know that I'm over 18. It's not like I'm sending all the information and they pick what they need. It's I decide if I send this information. This is the big difference. The user gets in control of their personal data again.
Most of the collaborations have relied on the immutability properties of the ledger, of the KILT blockchain, so kind of using the ledger as the trusted storage medium to retrieve DIDs for off-chain use cases mainly. But lately we've seen a push towards on-chain activity. We work on this DIP, which is the Decentralized Identity Provider, which is our take at trying to bridge identities cross-chain. The DIP is based on so-called state proofs. So you have your state on the KILT chain, you have your DID, which is a bunch of public keys. You could link different accounts to your DID, and then the DIP or DIP basically lets you go to a different chain and lets you generate this cross-chain proof, and then you're actually able to prove on the consumer chain that you have a specific DID, revealing only parts of your DID if that's what you want. And the benefit of having on-chain DIDs is that, yes, you can use it for off-chain interactions, but at the same time, as we do in our chain, you could actually use it as an authorization means for doing on-chain operations. So, for instance, if you have a chain where you need to vote, right? This chain might require you to present a valid claim that you've been a person by an entity that chain B trusts. So, of course, I could self-attest to be a person. The chain wouldn't probably trust me. But if I present a claim that has been attested by someone that the chain trusts, then I can actually access the vote operation. And if I don't have such a claim, if I'm not able to produce proof of such a claim, then I'm just not able to vote. And this allows you to basically gatekeep who can actually vote and restrict it to only people that have been proven to be actually human beings.
We looked around a little bit in 2018, so we were first looking into Ethereum. In Ethereum, it would have been like a smart contract that we built, and we found it a bit complicated to make a token economy which fits the identity space inside a smart contract, because we had the feeling, and I think that feeling was right, that that the system that we built is far too complex to put it into a smart contract. Actually, we said we need our own blockchain. Now, building your own blockchain is something that you normally don't do, because you have to go into mathematics and consensus algorithms and stuff like that. This is far too complicated for identity people. So that was not in the capabilities of our company. So we needed to look for something where we had a framework where we can actually build a blockchain. And by the time there were actually two of those on the market. One was Cosmos and one was Substrate for Polkadot. And we looked into two, and Substrate was very well developed by the time already, so you could actually use it, and the whole concept and the whole idea behind that was totally appealing. So this is actually where we want to be, same mindset, and a working piece of software which enables you to just build a blockchain in no time, right? Fantastic, without any mathematicians. So the others were not ready at the time, and also the concepts that we looked in were not 100% like we would actually see the world in the future. So we said, okay, let's try it with Polkadot. And then it turned out that the Polkadot community is totally nice, because it's full of people who are have the same mindset and the same ideas about how the world should actually be. And there may be more alternatives, and also Ethereum changed a lot. So when you look at the concepts that were in Polkadot in 2018, some of them have been adopted by Ethereum in the meantime. So no, I think we should stay with the community. We should stay with the technology, because also the Polkadot technology is evolving a lot. So Polkadot is ahead like 2 years, and it will probably always be ahead like 2 years, even though Ethereum is now as great as Polkadot was maybe in 2020, still Polkadot is now in 2024. The biggest one is, we just announced that is the so-called KYX project, Know Your Cargo, that is together with companies like Hapag-Lloyd and Vodafone. And the idea of that project is actually to track not only containers on ships, but also track the goods which are in the containers, because the European Union from 2030 on is demanding for every piece of cargo which lands in Europe that there is a clearly identifiable sender of this thing, which we don't have right now. So, but in 2030, they want to know, okay, who actually, if this comes from Singapore, who was actually the company or the person sending that? That looks very much like DEIDs. And for Deloitte, this is a huge, huge business, because that will be millions of different companies which have to be identified. And they do this with KILT. What I think the biggest adoption case that is going to happen is that DEIDs will be the basis of digital passports in the future. The American government is launching a project where they actually want to issue digital passports based on DEIDs and verifiable credentials to all American citizens by 2025, which is okay, ambitious, but maybe they make it. But when those people start using this technology or this standard, then there is no discussion about how digital identity should look in the future anymore. And in 10 years, it will be just the only possibility to log into something.
We think Identity Hub should be the evolution of People Chain. What Polkadot provides is basically shared security. So all the chains can be safe to use, but they're not really interoperable. So what Identity Hub aims to be is a place where all of these different projects, they can tap into each other's value that they provide and also into each other's user base. There's this concept of linked data, which allows you to aggregate data from different sources in a way that you can get more value out of the aggregation than what you would get in each individual chains. So the idea of Identity Hub is, okay, KILT will export, let's say, some of this identity stuff on Identity Hub. Other projects like Elite Entry could do the same, Doc could do the same, the People Chain could do the same, right? And then you have a place where all of the identity stuff about users is stored in a way that is structured and semantically unambiguous. What we think is a good way of storing linked data on chain is this RDF, which is a resource description framework, and it's a way of serializing and deserializing this linked data. For example, how we can convert regular sentences. For instance, Alice is 18 years old. This is what you would call this a claim. And in RDF terms, you would basically split that into 3 different components. You have Alice, which is the subject, and then you have the age property, which is the predicate. And then you have 18, which is the value of this predicate. And the core of RDF is basically splitting everything into 3 components. So it's called RDF triples, which you can then nest with each other. So you have the basic claim itself. It can become the subject of another claim. For instance, Bob certifies that Alice is 18 years old. So Alice is 18 years old becomes the subject, certified by become the predicate, and then Bob would become the object, which is the attester of this claim. You can now look up information about Bob and make a judgment whether you think Bob is a good source of truth for attesting the age about Alice. And this creates a data structure where you can definitely look up information about entities. And if those entities have been certified by other entities, you can look up the information of those entities and draw your own conclusions. It doesn't look inside the envelope what the identity information is. It doesn't aim to be the ultimate source of truth. It doesn't tell you who to trust, but it gives you all the tools for you to decide who to trust and who not to trust. Also the example of a Google review. So you have a place which claims to be a nice restaurant. Then you have a person leaving a review saying this was a good restaurant. And then you have people giving a thumbs up or a thumbs down to the review about the restaurant, right? So this is already like a 3-level interaction. RDF allows you to do that, but it allows you to go potentially 20 levels down. So you can have people attesting the thumbs up event about a specific comment of a restaurant, and then you can create these complex structures, which can be as complex as your use case needs. And we think this is the best compromise because it's highly used in the Web2 space. It's a language that they have been using for 20 years. First, I think it's still a problem that hasn't really been solved. It's really hard. Like there's a saying that on the internet, nobody knows you're a cat, right? And so that's what we're kind of trying to tackle here, putting a little bit of authenticity, in online interactions. Because right now, it's super easy to spin up bot accounts or fake accounts, and that's not really who we are. And I think if we add one layer or somehow that we know who we're talking to, in a sense, I think that will make things a bit nicer, I think, online. So you could have one chain which deals with, proof of personhood. It could be the encounter chain. They can do their verification logic, and then as a result of that, they could export this claim on Identity Hub. And now you have a bunch of claims where they say, this account is a person. And this has been certified by someone on the encounter chain. Once that information is on Identity Hub, you can access this information in a dApp, in an off-chain use case. But because it's on-chain, there could also be a different parachain, for instance, that requires users to prove that they have a claim on Identity Hub establishing that they're a person. And now, if you know that someone is a person, and you see also other claims about this person, for instance, you can start linking them together. So for fairly confident that this is a person, that they are part of some governance body or something, you can start making assumptions about this entity, this account. I would say that, so it is definitely harder to fulfill a lot of on-chain use cases as of the current design. For instance, we've gotten feedback about being able to verify credentials on-chain directly. So if you call an extrinsic, you not only basically authenticate it with your DEID, but you might also want to prove that you have a specific type of credential. For instance, you got a KYC credential from Deloitte, right? I might want to be able to only prove that I have a DEID and that this DEID has a KYC credential from Deloitte without revealing what my name is or anything else. Just the fact that I do have a KYC credential is enough for some use cases because I've been KYC'd by Deloitte. And how this information flows, it could be done via XCM, the standard way of doing it. It could be done with XCQ, which is this new cross-chain query language which is being developed. It could be done with DIP because, again, DIP has been developed by KILT, but it is generic over the use cases that it can be used for. We'd see that with GEM that would actually be even easier. So we're also looking at exploring how we can actually morph eventually into a GEM service and make basically a identity service for people to use, which would by design make cross-chain sharing way easier, cross-service sharing, I would say, much easier. We've been sparring it internally for I think a couple of months now. We have a rough idea how it would work on a technical level, but we definitely need and want to engage with the fellowship when it comes to proposing one or more RFCs about the topic. The next step would be to open a wish for change proposal and gather approval from the dot holders. We see Polkadot as the best candidate to try to capture as much value from the outside world as possible because of his heterogeneous nature, right? We see it as a system parachain. It could be the people chain, it could be a different parachain, and in the future we also see it very likely to be a GEM service, which would make, it would also make it easier for other services, which could be services that don't necessarily have to do anything with Polkadot, to access this information in a native place, because GEM would allow you natively to share this information between different services. And that's, I think, it would enhance even more the value that such a solution could bring. I don't know exactly how the current system parachains would be translated into services. I know that there will be a Polkadot service, so the current status will migrate as Polkadot. I know also that there will be few privileged services. I don't know if there will be other high-value services which will be deployed. I would imagine so, but I don't know. That's still too far in the future, and it's probably in Gav's head and a few other people's heads how that would play out. We just wait.